Air Force Fitness Program measures the overall fitness of its members based on 4 test components. Sit-ups represents 1 test component, and points are awarded based on how many sit-ups are completed in 60 seconds, the member's age bracket, and the member's gender. Write a Raptor algorithm that implements a simplified version of this calculation for members under 30 years of age. First, ask the user to input their gender as either male or female. Second, ask the user to input the number of sit-ups completed in 60 seconds. You can assume that the number of sit-ups will be given as a whole number. Output the number of points awarded based on the table below. Your program does not have to account for invalid inputs. To develop a solution for this problem, we remember our 4 steps. First, understand the problem. Next, design an algorithm. Then, implement an algorithm in Raptor. And finally, test the algorithm. Revisiting the problem description, we see that we have 2 inputs. The first input is the gender as either male or female. The second input is the number of sit-ups completed in 60 seconds. Then there is 1 output, the number of points based on the award table depicted. Designing our algorithm, we'll start by getting the gender, then we'll get the number of sit-ups. We'll store the input for gender in a variable called gender, and the input for number of sit-ups in a variable called num_sit-ups. Next, if the gender is male, we'll output a score based on the male column of the table above. Otherwise, we'll output a score from the female column. Implementing our algorithm, we'll start by saving our file as HW1-2. Then we'll add an input symbol to prompt the user for the gender, which we'll store in a variable called gender. Then we'll add another input symbol to prompt the user for the number of sit-ups. We'll store the result of that in number of sit-ups. Adding a selection, we'll check to see if the gender is male. If it is, we'll check to see if the number of sit-ups is greater than or equal to 52, and if it is, we'll output the number 9. If it's not, we'll add another selection to check to see if the number of sit-ups is greater than or equal to the number 47. If it is, we'll output the number 8. And if it's not, we'll check to see if the number of sit-ups is greater than or equal to the number 45. If it is, we'll output 7. If not, we'll check to see if the number of sit-ups is greater than or equal to 42. If it is, we'll output 6. And if it's not, we'll output 0. So we finished the male side of the selection statement. We'll copy this and reproduce it on the right side for the female. This time only changing the number of points awarded to 9.5, 9, 8.5, 7.5, and 7. We can test our algorithm with some inputs. We'll start with the gender of male and a number of sit-ups of 48, and we'd expect to receive 8. We can test it again with a female gender, and the number of sit-ups of 43, and we expect to get the result of 7.5. Checking our algorithm against the test server, we see that it passes all 18 test cases, so we might conclude that our algorithm is correct. Let's take a moment to look at some common errors. Perhaps the most common error is when checking for gender is to use a lowercase male. Note here that we check gender equals male with a capital M. Male with a capital M is not the same as male where all the letters are lowercase. The problem specification directed us to check for inputs of gender of male and female where the M and the F were capitalized. Making this error would cause a proper input of capital male or capital female to always go down the right-hand side and be treated as a female. A second common error is to output strings instead of numbers. Note here, 9.5 is not the same as the string 9.5. On output, the number 9.5 will be given additional precision of 9.500, whereas the string 9.5 will simply output 9.5. The test server will identify these as 2 different outputs. Although not an error, another common practice is for students to add additional but unnecessary detail to their selection statements. Note here where we check to see that the number of sit-ups is greater than or equal to 47. Many students will also add a Boolean check to see that the number of sit-ups is also less than 52, but this is unnecessary. Take a look at the selection statement above. If the number of sit-ups were greater than or equal to 52, we would have gone to the left. But if it's less than 52, we'd go to the right. Therefore, by the time we get to this selection statement, we already know that the number of sit-ups is less than 52, and we do not need to check it again. Similarly, many students will add an additional selection statement at the end of the cascading selection. Note here where we check to see that the number of sit-ups is greater than or equal to 42. Many students will add an additional selection statement beyond this to check that the number of sit-ups is less than 42. But that's not necessary, because if we are not greater than or equal to 42, we know that we are less than 42, and we could simply output our final score of 0.